Okay, there we go. Hey, all right, it is 11 p.m. Do you know where your children are? Sorry, so we'll go ahead and get started in the next couple minutes. Are we good to go on the tech side? Okay, yeah, Chef, thank you, Chef. All right, so welcome. There are many other places at MAGFest that you could have chosen to be. I can think of 5 off the top of my head that are big ticket items that even I wish I were there for. And you chose to be here, so thank you for that. Hey, thank you. Please excuse my voice if it goes out. I went to Rebecca Sugar and voice might be gone, yeah. The other disclaimer I have is it is very late. I turn into a pumpkin at like 9 p.m. Central. So we're really pushing it here. Luckily, I've stayed up late for the past couple nights, so we'll see how this goes. Because the last time I did a late night panel, we were struggling. So welcome, this is Pokébiology Z to A. Show of hands, who has seen Pokébiology previously, either here or somewhere else? Alrighty, do we have anyone from St. Louis? Not you guys. Anyone from, okay, cool. Cool, so you guys don't get to see it twice. It's kind of fun. All right, so my name is Connie Wall. As a little bit of background, if you have been to the panel, you know. If you haven't, hi. I have my bachelor's in biology from the University of Scranton, Pennsylvania, like the office. I did a second bachelor's in engineering at the University of Hartford in Hartford, Connecticut. And then I got my master's at St. Louis University out in St. Louis, Missouri. So those are my credentials. If you want to know what I do now, I work in quality. I laugh because it sounds silly, but I actually really like what I do. I work in life sciences, so I get to deal with biology and chemistry and how it affects products that go into actual like clinical uses every day. So those are my creds. Further disclaimers. I am employed. That's what I do. I'm a quality and validation engineer. All of my opinions and statements are my own and do not reflect on my employer. I'm also very tired. I'm doing great. I'm gonna stay up for the whole weekend, but once again, I am tired. I drove 13 hours yesterday. I have traveled from my parents' place in Connecticut to my house in Illinois to here in the span of 3 days. So please be very nice to me. So if I slip up, thank you. So if I slip up or have something that comes out of my mouth that you're like, actually, please come actually me after. But know that we're going here. The typical disclaimer. So Pokemon was not designed by biologists. It was designed by someone with great love for nature and great love for the biodiversity, specifically bugs, in Japan's environment, right? But it was meant to be fun. It was meant to be otherworldly. So, everything kind of has to be taken at face value. But thanks to modern games and people similar to myself who make so many good connections from the real world into the Pokemon world, they've gotten a lot better. So we have some more concrete examples of how we can connect our world to the Pokemon world. So we can still learn about things like ecology, physiology, evolution, and genetics. Very good ties to both the Pokemon world and our own, because mostly we've all gotten on the internet and said, actually. And they've actually listened. Like, honestly, they have listened. So that's really super exciting. All right. So, biology introduced. So we are at the time of day, and quite frankly, with competing interests at MAGFest, I assume everyone in here has some knowledge of what biology is. Vague. It can be vague. There are some people, maybe not, maybe you're here. Thank you for being here. The bar is open, thank you for being here. So biology introduced, biology is the study of life. So that comes from the etymology of the word, right? And to say something is alive biologically, we have 7 qualifications that we use to help define what is alive and what is not. So the first one is a basic unit of function. So for the purpose of my panels, I say that Pokemon have cells. That's just one of the base assumptions I am making. It's kind of like saying pi equals 3.1. I'm not the type of engineer that says pi equals 3, but bear with me here, right? So all Pokemon have cells. Structure relating to function. So this qualification's kind of fun because it's the favorite part of looking at Pokemon biology, right? Like, what does it do? Why is it there? Structure relates to function. So Caterpie has ribbed toes, just like a gecko, so it increases the surface area so it can crawl all over the place. So canonically in the Pokedex, which is right now my source of truth, I know technically I have a textbook now, I haven't read it yet, I don't think it's out yet, but according to the Pokedex, it has ribbed features on its feet that allow it to stick to any surface and climb everywhere it wants. So the structure of those ridges relates to the function of sticking to things. All right, we have the continuity of life. We still don't know how it happens. We just go to the daycare center. We say, have a nice day, and suddenly we are parents to more than one Pokemon. So the continuity of life, eggs. That's also a little sketchy, I will admit. We're not gonna go into why is it an egg. But we do have Pokemon, yeah, right? But we do have Pokemon that breed, right? We also have Pokemon that don't breed. So either way, continuity of life. There is a use of energy here too. We see this even more apparent in the more recent games where you can walk around and get jumped by something. That giant Litleo in Zeta A, I didn't see that coming. But the use of energy, it doesn't have to be useful. So Magikarp Slash, it's still moving around, right? You have growth. So starting in Ruby, Sapphire, and Emerald, you were able to catch different sizes of Shroomish. So you do see that Pokemon have the ability to grow as they go through their lifetime. And they respond to their environment. Once again, that Litleo, man, yeah, no spoilers there. That's the other thing. Back to the disclaimers. I haven't beaten Zeta A yet, so don't worry, there are no spoilers in here. It's just general chat. Cool. All right. So responding to your environment. All Pokemon come out of the wild grass. They come at you in a cave. They respond to their environment. And finally, adaptation and evolution. So this is almost like the other basis of the Pokemon games, other than catching them all, is watching them adapt and evolve, right? So Eevee here technically evolves into several different forms, right? All right. I thought I took this out. Well, we'll go through it anyway. That's fine. So when it comes down to thinking about biology, in both an ecological and physiological perspective, we think about these themes in even smaller terms. So for example, the basic unit of function, we can talk about molecules. We can talk about atoms. We can talk about tissues and organs. We do have to define at what level we're thinking about our unit of function, right? Structure relates to function. So this is one of my favorite questions to ask. Would you rather hit someone with a pool noodle or a printer? Raise your hand, pool noodle. Raise your hand, printer. All right. Everyone knows that you want to use the printer to hit someone with. It's heavy. And Lord knows I want to throw the one at work down a staircase, and I'm okay with that being on the internet. Because it stops working at the worst times, right? So what's easier to hit someone with, a pool noodle or a printer? Easier. Raise your hand for pool noodle. Raise your hand for printer. I respect it. I respect it. So structure relating to function, you also have to think about the limitations that that creature might have with that structure. Continuity of life. So we have the central dogma in our world. It may or may not translate over into the Pokemon world. But we say DNA to RNA to protein. So what is encoded in your DNA that gets passed down, plausibly, can turn into something that actually functions in a biological perspective. We also have use of energy. So Magikarp splashing around, it's still using energy because plausibly it is still undergoing cellular respiration. Our grass-type Pokemon are plausibly, once again, undergoing photosynthesis when they come in contact with the sun or the right wavelength of light. They grow. So how do we grow? Cell division and mitosis, baby. Response to environment, so this one gets a little bit tricky and we're going to talk about it more in depth in this panel. So cell signaling pathways, nervous systems, and endocrine systems all help you to respond to your environment. And this is going to include our mega evolution, which was the whole point in renaming the panel. We also have finally adaptation and evolution. So it's a result of all of the things on this slide and a result of all the change that's undergone at a lower level. So this is how I feel right now. So biology, therefore, has subcategories and subcategories and subcategories. So there is not one discipline that isn't represented in Pokemon. However, one person cannot know all of these disciplines fully. In fact, I forget how many taps I have on this slide. Right? So you're looking at Pokemon from all of these different perspectives. Not one person can know everything, which goes back to my disclaimer of I don't know everything. I worked as a marine biologist, I moved into tissue engineering and orthopedics, and now I work in quality validation. So I'll be honest with you, I touch equipment more than I touch squishy things. It's a matter of the discipline, right? It's the same way in the Pokemon world. We have different professors with different specialties. So every region you go to, they're looking at a different part of Pokemon life, which I think is very true to life, right? So you start out with, where are we? Oh, there we go. So we start out with relationships, habitats, evolution, and origins of life. So there's a whole discipline that we see, once again in Z to A, we're looking at the way that Pokemon are interacting in an urban environment. All of these Pokemon are flooding into Lumiose. How are they going to live? How are they going to live with people, right? So that's what Mabel is studying. Once again, I haven't finished the game, so no one tell me anything. But I love Mabel so much. Mabel is lover. You also have things like continuity of life, mega evolution, and acute abilities. I frequently say that a lot of my master's work probably would have been done under Professor Kukui, because I was very into understanding how specific tissue worked and how mechanics worked under it. Attacks and structure and function relationships go under this too. I thought I hit this one too, but going back to the original thought of the series, and honestly it ties once again very well into Pokemon Z to A, you want to know what is where when. So you're going to go catalog all of the Pokemon. So allons-y. Dug up my French for this. So starting out with ecology. So ecology at its base is the study of interactions between organisms and their environment. So once again, you can even look at Pokemon Legends Arceus, right? They're trying to understand what is there and how they're living in their environments, similar to what you're doing in Lumiose, right? All these Pokemon coming in. The original games, how many Pokemon are there? Professor Oak sends you out. Why? Surely not for personal reasons. Surely not. But understanding is really important because you can't understand how to live with it if you don't know where or what it is. So ecology asks what lives where and why. Lapras live in the ocean because they're kind of like sea turtles. How many are there? So when I was 10 and playing the Game Boy games, how many Zubat are in this dang cave? How do I get out of this dang cave? Like the ice path, for some reason, that just broke my little brain. I was running into Zubat for hours. So how many are there? And then how are they living? So Kamala are very much like koalas. They sleep for 18 to 22 hours. So they're going to find the tallest tree and fall asleep into it so nothing can eat it, essentially. So starting out with what lives where and why. So the original games did an okay job of giving you a biodiverse environment and kind of not just shoving you out into a field and having a random Pokemon generator occur, right? So we talk about these as biomes, so zones determined by the vegetation type or physical environment. And over the years, Pokemon has covered almost every biome there is. So we have deserts and forests, jungles and canyons. We also have saltwater and plausibly freshwater zones. So this bottom photo right here is kind of what I'm talking about. You have dark water and light water. When we could see the different types of water, I liked to think that the dark was salt water. I think that was the idea, and the light was fresh water. So in theory, you could find different things in different bodies of water. Now, obviously, that's not how the programming went. Once again, not designed by biologists, but it also gives you a good example of, hey, if I go to an estuary, if I have a mix of saltwater and freshwater, I'm gonna find wildly different things than I would in a freshwater environment. So I'm thinking Lake Michigan versus Long Island Sound. Cool, all right. Man-made environments. So I have fully switched the slide over because the whole premise of the game is that Lumiose is a man-made environment that these Pokemon are now living in. How do we live with them? It's interesting to explore, quite frankly, which is why I haven't finished the main game. I've put a lot of hours in just watching the Sandile swim through dirt. Still can't figure out how they do that. That physics is beyond my brain for some reason. All right. Oop. So what lives where and why? They live in communities, right? So sometimes Pokemon and animals and plants in real life will cooperate, right? So we have different populations of species living close enough to interact. Why did the transition see this way? Good evening. So populations, when I talk about a community, just like you and me, like a learning community, like a community of older folks, families, etc., that's going to be different things. A population is just one demographic, right? So we could have a population of Pokemon trainers in this room. We could have a population of biologists in this room, etc. Where was I going here? Oh, so Komalas live up in trees. Trees are tall. Can't get eaten if you're sleeping up in a tall tree. But also, what if you just lived where your food was, right? So we're going to find koalas in eucalyptus trees because they eat eucalyptus. Is eucalyptus good for them? Fun facts, it's not. It's actually kind of poisonous to them, but they've built up a resistance. So that's kind of fun because I can't eat onions. Doritos. Doritos are good. So Komala live in trees, so you'll find a population of Komala in tall trees where they can eat and sleep and thrive. That's where I was going with that. Okay, so we've asked where are they? We've asked why are they living there? And now how many are there? So gotta catch them all is gotta record them all. I found that was a really beautiful connection. So in real life, we do things like population studies and diversity studies, right? So when I was a marine biologist, there were two common ways of measuring what we found. So we would take a square foot pipe square. We would walk into the middle of like a rocky beach. Maybe we'd spin around a couple times. I don't remember how random we really made it. But then we'd throw it over our head. And what we'd do is we'd walk over to that transect and we'd count everything we found in that square foot. And we would do that a couple times to get an idea of what was there without going, hey, this rock has a lot of crabs under it. Let's count all these crabs. So it adds randomness, right? We also would put out traps on docks and see what swam into them. We would not bait them. We would undo the trap every other day. We'd count and measure what was inside, and we'd see and understand the trends of what was coming through the harbor. So it was like catching them all, releasing them all, but we would get good data from it. So it's easy. I wouldn't say it's easy. It can be tricky sometimes, but it's still important. Why invasive species? So welcome to the soapbox on the soapbox, not in the soapbox room. So an invasive species is a species which is expanded from its natural habitat. Now I have a big mishmash of things. So if you don't recognize these species, congratulations, you don't have this particular invasive species in your area. If you do, contact your local state environmental protection and see how you can help fix it. My first example is Japanese honeysuckle. Japanese honeysuckle came over because a lot of the people that colonized the United States thought it looked pretty. And they planted it. And it took over. And when I tell you, my yard in southern Illinois, I'm trying to get it out. I'm rent, so I can't do a lot. But Japanese honeysuckle is really big. It moves out all of the native species, which causes soil erosion. It causes habitat loss sometimes. And just generally, it gets everywhere. It's kind of gross, actually. What's this? Spotted lanternfly. How many of you live on the East Coast? All right, I'm guessing it's the bulk of the room. How many of you live in the Midwest? Okay, I see a couple hands, and these guys know it because they know me, but look at it. If you see one of these things, what you're gonna do, and everyone's already like, yeah, smash it. What you're gonna do first, if you live in a place where it is not prevalent yet, you are going to take your phone, you're gonna take a photo of it, and then you're gonna step on it. Then you're gonna send that photo to your state's environmental protection agency so that they know. Because the spotted lanternfly will decimate a lot. It decimates fruit trees, it decimates one of the oaks. It's bad. So remember, snap, squash, send. Cool? All right, soapbox number 1. So those are the 2 big invasive species in our own world. But Connie, this is a Pokemon panel. Yes, it is. And these 2 are considered invasive species. So when this panel was developed all the way back in 2016, I lost my mind with these 2, simply because the Macquarie Island story and the Rabbit Island story are real-life counterparts to what they put into Alola. So Alola actually took from real-life examples of, hey, we have something on this island, we don't like it. We're gonna bring in these Rattata, and these Rattata are gonna take care of it. Or this Rattata hitched a ride on a boat and is going to take over the island. So what are we gonna do? Instead of not bringing in something else that's also going to take over the island, we're just gonna bring in these young goose. Here you go, little guy, unlimited pizza, right? So this, once again, is a real-life Alola to Macquarie Island or Rabbit Island. So this is unfortunately a phenomenon that has happened multiple times, mostly in the Pacific Islands. So good on Pokemon, good on the Pokemon Company and Game Freak for bringing attention to, hey, don't let things outside that shouldn't be outside. Keep your cats inside. I will fight you on that. All right, so this is also a very old slide, but I still think it rings true. So by now, how many here play Pokemon Go? It's probably most of the room. Oh, interesting. So those of you who don't, if you have young ones in your lives, this is a fun activity to do. Go do a little ecological study. Bring it up on your phone. Yes, I know it's an algorithm. Yes, I know the spawns change. But it's a good exercise in saying, hey, what do we have here? Pokemon Go has different sizes. They have different moves. They have more complexity than I could imagine because I want to relax when I play a game. I don't get into the meta of anything. But it's good to kind of have that exercise for people to see what's in their backyard for Pokemon. Alrighty, quick recap. This is also for my sanity. So ecology, study of interactions, relationships within an environment. Biomes set the environment. Invasive species, new populations within a community. If you see a spotted lanternfly, squish it, snap, squish, send. All right, communities are groups of populations that interact, and most species are adapted to their specific environment. I say most because pandas exist. I'm glad you're laughing. Okie dokie. So, how do they live? So, just like you and I are interacting in this room where you're sitting there and you're going, wow, this lady's yapping. And I'm going, gee, I hope they like me. Pokemon will interact with each other in their environment, right? And that can be positive or negative. Invasive species can be positive or negative, believe it or not. There are species of crab that have been, at least on the East Coast since the 1700s, that we don't have a good idea of what it was like before they came. So we see the green crab, for example, that's an invasive species that just is here now. So we don't know if it's positive or negative. Versus the spotted lanternfly, that's pretty negative, right? Adaptation, the development of unique characteristics or behaviors. So the manga, I don't take the manga as gospel, but it's a fun read, it's a good read, and they were able to show Pokemon actually living in their environment. So like Farfetch'd, actually building the nest out of leeks. That's not something that you would be able to see in some of the older games. So Interspecific interactions, types of interactions, we have predation. So in an environment, who's having a better time here? Yeah, it's that Pidgeot. That is dinner. Who is having a bad time here? Caterpie. So one has a positive interaction, one has a negative interaction. Competition. So this is one of the few screenshots I could take that kind of illustrates the point. But you have competition for space. You can have competition for food. You could have competition for sunlight, which will come into play a little bit later. You also have symbiosis, which I realize, I can hear it, this is technically a parasite, technically, but like the Slowbro doesn't know what's going on here. Let's be honest here. There is helium in that skull, right? So really, symbiosis, because he no longer has a headache, actually, technically. So it's symbiosis, but I don't know. So moving on to the adaptations. So once again, you're living in this environment, you gotta learn how to live in it, right? So adaptations, characteristics, or behaviors which enhance survival. Macargo. I bring up Macargo because we cannot technically trust the Pokedex here, because the Pokedex says something absolutely wild about Macargo living at like 2,800 degrees Celsius, which that's really hot. I cannot begin to express how bonkers bananas that is. But once again, you're dealing with teenagers, 10-year-olds, that walked into a really hot cave, saw a slug made of fire, and went, wow, that's my new pet. So either way, they found Macargo in a volcano. Volcanoes are hot. If your body temperature is at a hotter level, you're not going to perceive your environment as hotter, right? That's part of the reason why when you have a fever, everything feels cold. It's because your body temp shot right up, which means the temperature difference between you and the room, huge, right? Whereas if you're like me and you're a little polar bear and you keep your house at like 62 degrees and you have sweatshirts on, you're perfectly cozy. It's because I have a very low temperature. I exist at a lower temperature than average. Happy in the cold, not in the summertime though. So Macargo is adapted to its environment by naturally being hotter, and to a 10-year-old, that's 2,800 degrees Celsius. Caterpie, we talked about Caterpie. He has the neat little ridges on his feet. He can crawl wherever to hide from predators, plausibly. And finally, Kangaskhan. There's nothing new here. That's a marsupial. It is carrying its young around, but that is an adaptation that helps the young succeed. All right. So bringing back the Rattata. Sorry, I don't actually know how to pronounce the rhythm. So I say Rattata. That's fine. We have Kanto Rattata and Alolan Rattata. So plausibly the Alolan Rattata morphed to a different color to survive better in their new environments, to camouflage better. And I started to think, what about a purple rat is such an advantage in like the grasslands of Kanto? And then I went, hey, Ekans are purple. So if you're a hungry bird and you're going through the tall grass and you're looking down below you and you see a purple thing, is it a quick and easy meal or is it a fight that you might lose? Predators may not want to take that gamble, so therefore Kanto Rattata are purple. Okay, I see nods. I feel validated, yay. The next one, I love him. He's so good. Like, I've been doing this guy was in the original panel and he stays here because I love him. He's ridiculous. So thinking back to the competition for space, right? If you are a executor and you live on an island in the middle of an ocean, there's not a lot of space for you to spread out and get sun and survive and thrive, right? Whereas if you're on a grassland, you're fat and happy and you have all the space in the world. So naturally, Alolan Executor are going to be taller because the tallest Executor will get the most sunlight, therefore the most power. Wiglet. Yeah. So adaptations, right? So Wiglet and Diglett are not related, and the Pokemon Company has actually even told people this because we all saw Wiglet and lost our minds, right? So Wiglet is actually a grass eel. They embed themselves in the substrate, in the benthics, and they kind of have their food come to them. which, genius move, they don't have to pay for DoorDash, right? Diglett are moles. They live in the dirt. They don't live in the water. I think my biggest pet peeve with the Paldean everything is that Wiglett are on the beach. To me, I'm like, they should be in the water, but that's a separate beef, I think. But that's actually an example of a different type of evolution. So you have divergent and convergent evolution, right? These guys are convergent. So they look like a Diglett. They're called Wiglett, but they come from two totally separate lineages. So Wiglett. And I saw a hand. Talk to me after. We're on a train. We're going. I'm so sorry. Finally, we also have these mushrooms, right? So we have fungus and amoongus, and we also have Paris. So they've adapted into forestry, right? When you go into, yes, it was Paldea, where you would walk around and they'd be so small, and you'd just step on one, and it would be like, dang it. There you are. So they've adapted to look like Pokeballs, so you'll pick them up so they can either attack you, get food, or come and live with you, much like a stray cat. So that's Pokemon Stray Cat. We also have Paris and Parasect. So Paris and Parasect may or may not be an adaptation. So Paris, cute little lobster bug, right? We love him. What is really going on with Parasect is that's a cordyceps. So that's a zombie, and it's meant to be a zombie. So really the adaptation isn't the Paris and the Parasect. It's whatever cordyceps analog is in the Pokemon world. So I'm sorry to ruin everyone's night there. All right. And finally, in the adaptations, we have Flamigo, which is literally just a flamingo. It's just the Pokemon's Canada Goose. And I just keep them in there, because boy, were they mad. All right, so I've talked a lot about interesting adaptations. How does it actually work? You're here for the juicy, juicy details, right? And once again, not designed by biologists, so take it at face value. This one's my water, okay. So I'm just gonna leave you with that real quick. All right, so we're gonna go back to the first part of the presentation where I talked about the cell as the base, right? So the cell does a lot. Cells do a lot in our bodies. And to do all of the wonderful things that cells do in our bodies, they use energy. And they use it through this molecule called adenosine triphosphate, or ATP for short, because if I say that multiple times, I'm gonna mess it up. They're gonna take my degrees away. So ATP is generated through something called cellular respiration. And if anyone paid attention in 7th grade biology, you would know that cellular respiration is performed in the, which is, graphic design is my passion. Congratulations. So for all intents and purposes, once again, plausibly Pokemon have cells, and there are mitochondria in them. Woohoo! So that's how we generate energy, but generating energy takes energy. So you cannot create something out of nothing, right? So how do grass Pokemon function, right? Is it symbiosis or physiology? So if we look at Bulbasaur, the bulb on its back gets bigger through every evolution that it has, right? And it actually starts to turn into a flower, it has more leaves, it can do more things. So we're assuming here, once again, lots of assumptions, that by growing, exposing it to light, it's undergoing photosynthesis, which takes a huge chemical reaction, takes the energy from bouncing photons places to build sugar. And then that sugar is broken down in cellular respiration, right? Until you get this big bad boy. Love him. There's a large flower on Venusaur's back. The flower is said to take on vivid colors if it gets plenty nutrition and sunlight. It also soothes the emotions of people, which I think is rather nice. But once again, as you see, you have this big flower. It is making all of this food. It's storing all of this food. It's doing wonderful things. And you get solar beam at some point, which is also why you have to recharge solar beam. Not only is it a highly overpowered move that would just decimate an opponent if you could use it one right after the other, but also, like, that's a lot of photosynthesis that you just used. Respect your Venusaur. So that being said, do we need to feed our grass-type Pokemon? Raise your hand if you think yes. All right, raise your hand if you think, nah, they make their own. All right, so interesting news, carnivorous plants exist. So carnivorous plants give plants something other than sugar. So photosynthesis gives you one form of food. It does not give you other molecules, other nutrients that you need to live. So the answer is please feed your grass-type Pokemon. Because they need nitrogen, they need phosphate, they need other good things to live. All right, so moving on. So, okay, you have energy. How do we use it? You can build proteins. Ask me about building proteins. I spent a lot of my time in school reading about proteins. So, yeah. So, making and exporting the structural building blocks for tissues. So, cells are little factories. One of my beefs with cells at work, on a quick aside, is that we never get to see the actual cells doing things. They're just in apartment buildings. And I think that's not accurate because they're producing, they're crafting, they're knitting so hard. So that takes energy to do and to upkeep bodies. So things like collagen, elastin, fibrin, and keratin, they're so important, especially for Spoink. Especially for Spoink, right? That poor little dude, if he stops bouncing, it's done, right? So he has elastin. He has those bouncy proteins that help him to keep going even when asleep. All right. We also have things like calcified tissue, once again, my jam. So you have steel-type and rock-type Pokemons. The building blocks, that rebar, that's protein. We have specialized structures. So Smeargle, his paint is just like weird colored mucus. There you go. I'm just going to leave that there. We also have cell signaling. That takes energy too. So relaying messages from cell to cell, building up your cell muscles, that takes energy. And finally, heat. Cellular respiration is a combustion reaction, so you're all on fire. All right, that's it. Thank you. Thank you. Don't tell my partner I said that out loud. All right. So here's the deal. I've talked a lot about food, and thank God I've eaten dinner, but getting hangry. So let's think about this. So we need energy. We're not photosynthetic, sadly. How do we know how to eat? How do we know how to fuel our bodies? The answer is homeostasis. Homeostasis is the need to be in a stable, balanced situation. And that's the best colloquial way I know how to put it. You never want to be at any extreme. And Morpeko, though that's two extremes. I sympathize greatly with Morpeko. I have Crohn's disease, so I'm either happy or I am angry, right? So how do we know? Hormones. Hormones tell us when to eat and a lot of when our body isn't feeling quite right. So Pokemon and Game Freak got this really, really good. So when experiencing prolonged hunger, the balance of hormones within Morpeko's body changes. This causes its fur color to change and triggers more aggressive and volatile behavior. Once again, kind of like me. So this is something called a neuroendocrine reaction. So we have two different body systems talking to each other and saying, hey, we need to fix this, and we need to fix it now. And looking at Morpeko, it's pretty obvious because the fur color changes, but how does the fur color know when to change? That's a very physical reaction. So glucose, insulin, and ghrelin are the three that really tell us that we're hungry or tell us when we're satiated. So those of you who maybe have diabetes or need to watch your blood sugar, you're very well aware of that glucose-insulin connection, right? Ghrelin is a different type of hormone that actually signals the hunger that you have. So that goes to a totally different part of your brain, which I think is really interesting, and I think that's what Morpeko really is telling us. Additionally, not just Morpeko. So when you have Pokemon that maybe need to hibernate or brumate, and they're not going to be eating all winter, they're going to have their hormones tell them what to do. Snorlax and Munchlax, really great example of that I hadn't thought of until maybe like 2 panel cycles ago. But they're also there displaying hormones. Sometimes you just want to sleep. What a mood. All right. So when we're talking about signals, so chemical is hormones. So these are fatty molecules in your blood that attach to certain receptors. And It starts with a stimuli. So a stimuli is anything in your environment. I'm not even kidding. It could be the temperature. It could be a sibling, like, not touching you. It could be the smell of a pizza, right? That is a stimuli that is telling your brain something. This actually triggers an endocrine organ to do something. So it's like, hey, you're right. We haven't eaten for a little while. Let's do something about it. That endocrine organ is going to release hormones, which go to a target organ, and give you a response. So that ghrelin goes to your brain is like pizza, now. And you may or may not respond, right? So I'm using food, but the whole idea here is in Pokemon Z to A, we have mega evolution. And this is the first time in this panel that I have talked so extensively about this because of Z to A's mega evolution. Everyone's like, how does this even work? Your megastone is the stimuli. And weird things happen, right? Ampharos gets good hair. Love Amphi. He's my favorite. Starmie does something. I forgot about that until I put it into the panel this afternoon. And I turned to my partner, I was like, what did they do here? Oh God. And then you have Blastoise too. So Amphia is a mammal. That's a sheep, kind of, sort of, sure. We have Starmie, who is a starfish, who is an echinoderm. Turns out echinoderms also have hormones and adrenaline response. Fun facts. So do reptiles. So for some reason, Game Freak got that right too. We are just giving our poor little Pokemon an adrenaline rush every time we want them to battle better. Who knew? So here, once again, just to kind of loop it back around, stimulus, megastone activation, goes to whatever adrenal glands that Pokemon has. Adrenaline, straight to the receptors. Absolutely everything. When adrenaline, that hormone, is in your body, it hits every receptor you have, and your tissues are going to react differently, right? So everything. It could, if you're an Ampharos, spark hair growth. If you're a Starmie, suddenly you have really long legs, because it's going to affect those tissues, and those tissues are going to respond acutely and quickly. So Ampharos with the good hair. All right, sliding into home base. Whew. So we've talked about a lot, but we're going to loop back to the origins of Pokemon. So the fossil record, what is found in the ground. And even in Pokemon Z to A, we are still resurrecting these dang fossils. Jurassic Park tells us that we shouldn't, even though we can. But that dude in Maple's lab was like, yo, give me $1,000 in a fossil, you'll get a dinosaur. Okay. So the fossil record, what is found in the ground or in your Pokemon team, right? In the Pokemon world, we also have a written record. The games are starting to kind of come around to this idea of like lore that is easily accessible in a game, which is kind of nice, because back when I was like, 10, 11 years old, I had to figure out what the hell that was saying. And that was a little tough for 10-year-old me on my little Game Boy in the back of a car. So we have a written record, nevertheless, in the Pokemon world that tells us what existed beforehand. And in the Pokemon world, as well as our own worlds, we have unchanged surviving species. So we have Relicanth, who is a direct connection to a coelacanth. We have coelacanths. Mamoswine, we don't have mammoths anymore, but Pokemon does, and that's pretty cool. So they can kind of see their evolutionary history just walking around on the streets of Lumiose. We also have horseshoe crabs in real life. So this is where my soapbox is. Pay attention to what happens to horseshoe crabs. Horseshoe crabs are very important. They have not changed for millions of years because their design is perfect. And when I say their design is perfect is when they flip over, they can flip themselves back over. So if they're belly up, their tail whips around, turns the right side up, and they go on their merry way, and they don't get eaten by seagulls. And they've lived this long. Like, what goals, right? Horseshoe crabs also have a special type of enzyme in their blood that allows them to take out any bad things in their blood, so viruses, bacteria, clumps up, and they essentially excrete it out. Their blood, because of that property, is used for scientific clinical testing. So anything that gets put inside your body, Anything that, quite frankly, goes near your body undergoes an LAL test, which uses horseshoe crab blood. And because we live in a capitalistic society, businesses have taken advantage of this. So they'll go fishing, they'll get blood, and they'll re-release. Depending on the state that you're in, there are catch limits. Contact your local lawmakers to make sure there are catch limits, because we want to make sure that this is sustainable. Because right now, it is the gold standard. They're working on substitutions, but it's not very quick. So if you feel so inclined, talk to your local lawmakers, get involved with horseshoe crab tracking. I know the state of Connecticut has a program. I know New Jersey, University of Maryland has a good program. Get into tracking them. And if you see one on a beach and it's just hanging, let it be. If it has a tag, feel free to take a photo of the tag and report it back so we know where our horseshoe crab friends are going. Yay. Now that I'm on the East Coast, I can say that. Midwesterners look at me like, beach? I love you guys. Sorry. They're scowling at me. Love you. All right. So now we're going to talk about the whaler in the room, or the whale lord in the room. And I don't mean Skitty. So this comic is from Super Effective, and it says, what? Bulbasaur is evolving. Congratulations, your Bulbasaur has evolved into Ivysaur. No, it didn't. I regret to inform you, dear viewer, that that old man is right. And I'm going to tell you why. I see nods. Do you know the answer? Okay. So the E word, let's talk about it. So evolution, from a biological perspective, is descent with modification, typically passed down through generations. So this is where Charles Darwin had his whole big moment, where he went to the Galapagos and mapped out different types of finches on all the different islands in the Galapagos. Metamorphosis, developmental transformation that turns an animal larva or juvenile stage into an adult or adult-like stage. I'm going to let you sit with that second one for a second. Before returning to Charlie Darwin. So descent with modification, so these are the finches. So they're adaptations with a genetic factor. So it's something that you have that allows you to be able to carry on the genes successfully, and allows that your offspring has the same adaptation as you so that they're more successful, right? This is done by a process through natural selection. So once again, if you have a beak that's really good at opening seeds, and that's what's on your island, and your kids have that beak, they're gonna go on and pass that beak down. In the Pokemon world, we kind of see this in shinies. So if you think about it, these are disadvantageous adaptations that plausibly come from a genetic factor. So if you are a purple whale lord, you may not find a mate. Yeah, big aw. Big aw. If you're a red Gyarados, you may be so aggressive that you can't get food. You scare all your food away. You scare all potential mates away. If you're a pink Schviel and you're on some rocks, and you're not blending in like the other Schviel, you are dinner. And that is sad. So natural selection in the Pokemon world is essentially our shinies. That's our big one. There's a really cute Dorkly comic by a cool artist who may or may not be in the Artist Alley this weekend that talks about the Wooper, the shiny Wooper for the albino younger brother. It's so cute. You should go Google it. I should have it on here. But once again, shinies, love them. Take them out of there. Give them to someone who will appreciate them, because they will not make it very far. So phylogenies. So how do we track all of this evolution? So evolution is from generation to generation. And if you're talking about things like fruit flies, that's fairly more straightforward to track than something like Galapagos tortoises, right? So researchers will use phylogenies to kind of track these big changes throughout species and demonstrate the relationships. So someone, a phylogenetic tree is depicting those visually. So someone, Shalomi et al., actually got to do this and mapped out every Pokemon. This was back in like 2012. So it was back when we only had 1,000 Pokemon, which, that's a sentence. The 1,000 was normal. But making these is difficult. So you can't see it very well, I think, on the big screen, but they mapped it out as Mew from the progenitor. And they just went wild with it and connected it back, so through common ancestry. And they do use software to do this. They're not just kind of like hand doing it. So there is some programming involved. So if you don't like squishy bits, there's room for you in biology if you like tech too. Making them is difficult. So we have evolutionary connections here, but I said that Pokemon evolution wasn't actually evolution, so what is it? Metamorphosis. Developmental transformation that turns a juvenile stage into an adult or adult-like stage. Don't that just sound like Pokemon? But let's be honest here. If you have a 6-year-old and he wants to say, hey, my Pikachu metamorphosed into a Raichu, you'd be looking at that kid like, what's wrong with you, right? So hence, evolution. But if you think about it, the baby Pokemon are the most accurate version of metamorphosis that we have in the series, because as a Togepi, Togepi will not make another egg. Togepi is an egg. So you have this like larval stage, right? And then finally, once you hit an adult stage, you can drop it off at the daycare and get more Togepi, plausibly. So baby Pokemon, most accurate form of Pokemon metamorphosis. Pokemon evolution, actually Pokemon metamorphosis. So if you want to actually your friends into oblivion, whip that one out. You're welcome. So, quick recap. We talked about the fossil record. So, remains found indicating past species could also be written. We have evolution, which is a descent with modification. Metamorphosis, transformation from juvenile to adult, which is Pokemon evolution. Phylogenies, evolutionary relationships, which are displayed on phylogenetic trees. Oh, we did it, Joe. So, we talked about these things today. I'm not going to read them out because it's late. But this is what you learned in under an hour. On a Thursday night at almost midnight when you could have been at the bar. That being said, go forth if you would like. But at this point, let me give you some citations. I don't own this. Do not come for me. I do, however, I did do these slides, so that's pretty cool. This is the citation in MLA format for that phylogeny paper. The QR code that I used to have does not exist anymore, so please plug that bad boy into Google Scholar if you would like, and I will pause here. And the comic that I put in there is from Super Effective number 50. That should be on the internet somewhere still. Oh, and Campbell Biology was my best friend when I originally made this. All right, final acknowledgements. These are the people who have helped me a lot with noodling and bouncing ideas off of it. My partner, Andy Cluthy, is at booth 04. Talk to him about Dorkly. And sorry, Mom, that's me. All right, I will stay here. What I will do, I have a little helper. If you have questions or want to actually me live on Twitch, I'm gonna have my little helper go and help me choose people. So get up here so you can. What I will ask you to do is either shout your question, I will repeat it, or come up to the mic. Pick people. They're saying some stuff. Thank you for being patient, everybody. Hey.
I know you mentioned about Mega Starmie. It's actually based on a 1965 tokusatsu movie where their aliens are shaped like that.
Yeah.
And also because Starmie's been alienified repeatedly in the decks as well. So
that's very true. So I don't cover aliens, so thank you for that.
Yeah.
Yeah.
Hello.
Hello.
Have you heard about the World of Pokemon website? It has like a lot of the things you covered, especially like the ecology.
Do you
the
want to come up
habitats.
afterwards?
Yeah, I can
and
do
show
that.
me? Because
Yeah.
also, like, do these people need to give me more credit? Is I guess my.
I know. I just
Hi,
found it like
Twitch.
I just found it as like a cool overlap.
Yeah.
and
No,
whatnot.
I would
I'll
love
show
that.
you afterwards.
Because once again, I've been doing this for 10 years as of this year, so I'm like, yikes.
I don't have a question. I just
Yeah.
wanted to show you a picture.
Yay!
Okay.
Sure. Oh my god, the thumbs from Spy Kids and the Mega Starmie.
That's Megastar.
Good call. This is turning into Pokemon crazy posting after dark.
So I actually have a question regarding the humans in Pokemon, specifically because of how absurdly durable they seem compared to real life. How many times have we seen Team Rocket be
Okay,
blasted into the
I have the
atmosphere?
answer for this. I don't talk about the anime. I have no answer for that other than anime. And for some reason, they're kind of like Olympians and like they're otherworldly. All right, yep. Yeah, in the games is also a little sketchy.
And also the player character
He's
of
built
Legend,
different.
the player character of Legends Arceus too.
Yep.
Keeps
They're
surviving every Pokemon attack with minimal damage.
just built different. But
Yeah,
thank
every
you.
human in the setting must be
Yeah.
must just have like 10 times the durability of what we've got.
Absolutely. All right, I'm gonna take two more. So the guy in the beanie, and then I'm actually gonna get off stage because there is another panel, and then y'all can just meet me in the front, and we can all crazy pose together. Yeah.
Hi, rogue marine biologist here. I have one I'm actually and then a question. The I'm actually is since I work way too much with the Invasive Species Act, or Endangered Species Act, and then invasive species. Invasive species are by definition introduced by people. So I think that would be helpful to add
Yeah,
to
no,
your
that was
presentation.
me.
And then my question is, what is your favorite protein? Because mine is hemoglobin.
Mine's mucus.
But yes.
Yeah, mucus is great. My favorite protein is mucus, and I'm not afraid to admit that on the internet. It's awesome. It does a lot of stuff. Yeah.
Hi, my question is, do you think there are enough Pokemon species to form a functional ecology?
Yes.
Okay.
Absolutely. So the question was, do you think if there are enough Pokemon species to form a functional ecology? Absolutely. I think especially now we're at the point where Game Freak and the Pokemon Company have understood that we want a little bit more realism, that we're kind of craving understanding and being in that world. And I think they've done a fantastic job at covering that. So.
Thank you.
Thank you. All right. I'm going to take your question offline because there's another panel coming in. So meet me right, if you want to meet me right over there. Yeah. Thank you. Have a great mag, everybody. Stay safe.